Hello there and welcome to this workshop on anomaly detection with Python. My name is Valentine and I'll be your instructor. In this session, we are going to go through the learning outcomes at the very beginning. After that, we'll talk about what anomaly detection with Python entails, why we would want to perform anomaly detection, and then later get into a practice session where we will explore different anomaly detection techniques using the Python programming language. Towards the very end, we'll just talk about the next steps. So let's get started. By the end of today, we are expected to have achieved these learning objectives. We should be able to explain the fundamental concepts and the importance of anomaly detection in data analysis. We should also be able to identify various anomaly detection techniques and the appropriate use cases. We should also be able to implement different anomaly detection algorithms in Python. So what is anomaly detection with Python? So this just involves the process of identifying rare items, events, or observations or data points that differ significantly with other or with a majority of the data. So it could be that you might have a data set of transactions and you can be able to identify those records which are anomalies, which are significantly different from the rest of the records using anomaly detection techniques. In some cases, you might hear of the word outlier detection, which just means the same thing. And these anomalies or these records that differ significantly from the majority normally would indicate maybe critical incidences or faults or defects or even just fraud. So it depends with the domain that you would be working in. If it's in finance, that could be, those anomaly records within transactions data might be treated as they could be genuine, by the way, but in many cases, in certain cases, not many, but in certain cases, they could be treated as records which are fraudulent in nature, and they could, be investigated and further actions can be undertaken. In healthcare, it could be that maybe patients are have some sort of rare disease, or they do show some rare sign to a particular. Maybe it could be to maybe treatment, and it would allow stakeholders to be able to make other recommendations once they have noted the rare occurrences of such observations. In cybersecurity, it could be that there could be patterns within network data that would suggest that most likely there has been some sort of intrusion on the systems that are in question. So so in many contexts, anomalies can mean many different things, and it could mean good things, it could mean bad things. Like, for example, in manufacturing, if an anomaly is detected, then that can be set aside and not be included with, say, the rest of the records pertaining to the products that are being produced. It could mean that maybe that particular record that has been singled out is a defect, and which helps organizations be able to maintain standards. A use case of this particular process or anomaly detection would be in credit card fraud detection. So this is another use case where one might want to identify unusual spending patterns that deviate significantly from the normal customer's behavior, which of course would potentially indicate fraudulent activity. Just to go through a few more use cases and reasons why we would want to perform anomaly detection. So we might want to perform this technique or the related techniques to identify fraudulent activities if there are unusual patterns, which essentially helps organizations prevent financial losses and protect customers' trust. We could also get to be able to detect irregular network activities if we are to apply anomaly detection techniques, and this might help prevent cyber attacks or even unauthorized access to systems, which ensures integrity and security of just sensitive data. It could be healthcare data, it could be banking data. It also, performing anomaly detection allows us to be able to also identify anomalies in machine operations, which it just helps organizations to note, equipment fails and reduce the downtime and maintenance costs associated with the anomalies. Anomaly detection can also flag defects or irregularities in manufacturing processes. I've talked about that already. And it can also identify inefficiencies or unusual patterns in operations, which would result to helping organizations optimize and reduce costs, essentially. So these are just a few reasons why one might want to perform anomaly detection. And as a data scientist or a data analyst, it's important to also equip yourself with the mentioned techniques pertaining to anomaly detection, more specifically with Python. It could also be with R, so that you are able to note and also apply or create solutions that address problems of this nature. The techniques that we're going to be learning in this session, there are a lot more anomaly detection techniques, but these are just some basic and essential techniques when it comes to anomaly detection, and they would be feasible and have already been proven to work in many use cases. The first one would be the box plot method, where you are able to just identify outliers within univariate data. So if you have a data set and it has many columns, you can create box plots for each and every numerical column and be able to visualize the spread of your outliers and of your data, and be able to note the outliers as the ones that are significantly far from the majority of the data points that you have in that variable. We'll get to implement that using Python, but in most cases, creating a box plot is usually one of the basic things that you get to learn when you're starting out your journey as a data scientist or analyst. The IQR method, or the interquartile range method, allows us to be able to identify, again, outliers. It's still more so the same concepts applied in box plot, but in box plots, normally you visualize the data points themselves and see whether there are data points within a variable. But with the IQR method, you're able to retrieve those data points using techniques associated with the interquartile range. So there's a formula, as you can see there, Q1 minus 1.5 times IQR, which allows us to be able to determine the point at which, if points fall below that particular point that will be calculated through the use of that formula, then we can conclude that there are outliers within our data set. And the same case happens to if they are way above the point at which we arrive at using the second formula. That's Q3 plus 1.5 times IQR. Disease course method, it's also another type of method that we can use to identify outliers based on how many standard deviations there are away from the mean. Just like the IQR method, you're able to not visualize, but you're able to retrieve those records. But again, this is dependent on the number of standard deviations that you would want to work with. KNN is another method. K nearest neighbors method allows us to detect anomalies by calculating the distance of each point to its K nearest neighbor. So what KNN does is that it determines a point for each and every record that you have in your data set. And then it calculates just distances between that new point or any point and its other associated nearest set of points. So that's K nearest neighbors. If you have maybe two nearest neighbors or maybe three nearest neighbors, then you introduce another point which is representative of a record. K nearest neighbors would determine whether that particular point is an anomaly based on how far it is from now those nearest neighbors. So on the other hand, one of the also most used method for anomaly detection, and it's usually the highly recommended one, is isolation forest, which uses it's an ensemble based approach, which uses decision trees to be able to isolate anomalies, or to be able to single out anomalies by just partitioning data and identifying points just that are in similar partitions. So this particular technique uses multiple machine learning techniques to be able to identify outliers within a data set, hence the reason why it's called ensemble based, because it uses multiple trees essentially, and as a result you're able to get your outliers. So we'll get to implement these techniques using the Python programming language, and by the end of it all you should feel confident that you can be able to work with a few of these. The idea is that if you acquire these skills, you can apply them in just projects and work towards, you know, creating solutions, effective solutions for organizations, or even coming up with new products. So yeah, so let's get to see how we can be able to apply them. In the video description of this course, you can click on the practice resource link that should take you to a page that looks like this. Then click on sample practice resource. If you're an Afterwork member, you should have the practice and the solution resource. We are going to be using the practice resource, but if you are new, just click on the sample practice resource. It should just give you a few challenges, but again, if you want extensive challenges, consider to become an Afterwork member, which just gives you a whole lot of resources at your disposal that you can work towards. So yeah, so let's get started. So once you have gotten here, click on File, then save a copy in Drive. You should save a copy in Drive in your Google Drive, and it will create that new copy in a new tab. Then you can click on that, and then you can close the original one, so we don't need that. For me, I'm going to use the practice notebook, and if you're an Afterwork member, you can do that same, use the practice notebook. I won't open mine in save a copy, but if you can save a copy. I'll just open mine in playground mode because I don't want to create another copy. I already have a copy. All right, so once we have done that, we are going to first of all import the pandas library, which will allow us to perform data manipulation. So we will load data sets into a data frame. We will load a data set into a data frame, which is pandas data frame, which will be able to apply some data manipulation techniques and work with that. So let's go to prerequisite and run that. It should take a few seconds for the first time, and then we are good to go. All right, box plot method. So we got to see that we can be able to work with box plots to visually represent just to visually identify outliers. And what a box plot does, it helps us to represent or visualize the distribution of data. So it creates what are called it has what, but essentially we create a visualization that allows us to be able to see how distributed the data is. But in addition, we're also able to detect potential outliers. So if we are to load this data set, we can see we have the following information. But what we're interested in is the numerical values, the variables. So these ones that you see here. So what we are going to do is to select those numerical columns. We create a list, and then we select those columns using data, then pass the list to the data and select the selected data frame. And then once we do that, we visualize now the box plots. We create box plots for all the columns, and we can do even just one by just passing the number of that one variable inside the list that we see here. But yeah, so then we display the box plot. So if I run this, I should be able to see our visualization. We can see we have multiple box plots, and if I think it's a bit too large, let me just reduce this a bit. I think this is okay. So we can see that we have a box plot here. Just means the points are just around here, and the points that the scale here, it's actually quite large, which means some of the box plots you might not be able to visualize clearly. So, but for loan amount, we can see there is a dot that we see that's on the line here. The line here is a whisker. A whisker is what we have on the top of the box. This box over here, this is a box plot of the income variable, and at the center we have our majority of points that they lie between this point over here, that's around, it should be around 5,000 or 4,900, and 8,000, not 4,000, 40, around 30,000 or 29,000, actually 32, 31 or 32. Same case with over here, it has around 90,000. So generally, a box plot just allows us to be able to see how well the data is distributed. But points, we see points over here, like what we are seeing here in loan amount, it means essentially that we have some outliers in this case. So yeah, but a box plot just allows us to visualize the distribution and note that there are outliers. So in our loan amount, we can see there are outliers. So what we are going to do is to identify later onwards what those outliers are using now different techniques. Right, but to implement now what we have seen, so we but here, by the way, here we just set the size of our plot. So if you're not sure, we used we used box plot function from pandas to be able to set that. Pandas has some data visualization capabilities, but not extensive, some basic, but we can set the size of the X dimensions using 12 and 6, using the first value here and the second one over here. All right, pause the video and then work on the challenge. We can then decide to identify outliers or to get the outliers based on one particular variable. So in our case, the technique that we are learning here for box plot, it allows us to investigate individual variables. The same case with IQR. The IQR method allows us to do the same, but we would now need to remember those formulas I had mentioned earlier. We would need to determine this particular value, Q1 minus 1.5 times IQR, and also Q3 plus 1.5 times IQR. And the idea is that once we've determined those particular values, we can then determine outliers as or identify outliers as those points which are either below the value that we get from here or above the value from this value over here. So to actually calculate the values of those IQR in a data set, so let's first of all load this data set and identify which column we're going to be working with, which numerical column, which is amount, and then we now decide to work towards identifying the values. So for Q1, which is data amount, and we want to apply the quantile to be able to get the first quartile, and we set that normally it's usually at 0.25, and the third quartile is 0.75. So our IQR as well is what you see here, the difference between the two, and then the bounds, the values that we are getting from these formulas, this is what we are getting, the two values, lower bound and upper bound. And then we now determine those points, like, those points which are lower than the lower bound and than the upper bound, and we use an unsigned. Here we're just using Boolean indexing, so for that. And then we store those outlier values here and we display them. So if I run this, we will be able to display the outliers based on the amount variable, as you can see. All right, pause the video and then implement the challenge that you get in IQR. Moving on, we might decide also to use the Z-score detection method to identify, or Z-scores to identify outliers in a univariate data set. So we could decide to use this method. And how this method works, it just allows us to determine outliers by measuring how many standard deviations a data point is from the mean. So So first of all, what we need to do is to, let's say, load our data set. But again, we're also doing this for one variable. For box plot, we would visualize for one variable each. It's only that in our case, we decided to visualize for multiple variables, but it's usually for just one variable. For not box plot, IQR, it's only one variable, which we did amount. For Z-score, it's on, or Z-score, it's also another variable itself. So in our case here, we are going to calculate the Z-score or Z-score for data transaction. So we identify the mean of, to calculate the Z-score or Z-score, we would identify first of all the variable of interest, transaction amount, calculates its mean, as well as the standard deviation of that particular column. Then we use these pieces of data, mean and standard deviation, to calculate the Z-score, which usually would be the point itself that we want minus the mean divided by the standard deviation. And then we are able to set also a threshold to be able to say that points that which are outside this particular threshold have are actually anomalies. And then we once we've set the threshold, we then decide to flag those anomalies based on that threshold by using the apply function and a lambda function. Here we just simply applying this function where we want to check for if a point, if the Z-score point for each and every transaction amount is less than -3 or +3, which is more than 3 standard deviations, then if it's less than 3, then it's, or greater than 3, then it's an anomaly, or else it's normal. It's just, so those are the values that we essentially create a new column here called anomaly, and then we perform that operation of assessing whether the value for the Z-score value for the respective record for transaction amounts record, is it the value for transaction amount for each and every record actually is either anomaly or normal. So, and then we actually replace if it's less than or greater than 3. So if the Z-score for transaction amount for 200 is less than or greater than 3, then we assign anomaly to that new column for that particular record. That's for that anomaly. Else we do the vice versa. We just say it's normal. And then here we're just displaying now the new data with just a few columns, the transaction amount, the Z-score, as well as the anomaly. So here if we run this, we should be able to see the Z-scores. As you can see here, our threshold is -3 and +3. So here we're just seeing minuses, which these are all normal. But if we get to filter using still Boolean indexing here, we want to check for the records with anomaly, we can be able to do that, and we should be able to see that we have a few, the Z-scores for these ones greater than 3. So these ones are treated as anomalies. All right, pause the video and then work on the challenge. All right, so far we have been able to work with anomaly detection techniques for just univariate or for just one variable. So assuming that we had multiple variables, so how would we go about that? We can use these two techniques. So the first one is KNN, the second one is isolation forest. So to work with nearest neighbors, this KNN algorithm, we import the necessary library, then we load the data set, and then we can decide to specify the feature. So here we are going to only have this amount, because in our case here we only have amount as the numerical variable in this data set. That makes sense. So we can just specify that as a feature, and then we initialize our model, and we can specify the number of neighbors that we want to work with. Let's say 5. You can always change this to whatever that you want, depending on whether the outcome actually works best for your case. Sometimes you might get anomalies that are not really anomalies, so you'd have to adjust the 5 here. because once you get anomalies, you need to investigate them further. Then we fit our model, and then we calculate the distance to the nearest neighbors for each data point. That's what we said k nearest neighbors does. You have these two variables and the indices, and then we define a threshold for flagging those anomalies, which we are able to identify and flag those anomalies using this particular filtering technique. And then we store the anomalies in the anomalies variable and display the flagged anomalies. Like, for example, here is the list of flagged anomalies for our case. You can compare this with the, no, these are different, with this one. So the IQR method that we see here, for IQR, we can compare the outcome. So we can see 317.23, and also for KNN 317.23, and for KNN, sorry, 317.23. So they actually give us the same same outcome. All right, moving on, pause the video and then work on the challenge. Moving on, we'll go to isolation forest detection. So this technique, it's a machine learning technique that we can use to also isolate anomalies, and it's one of the most efficient techniques. So how does it work? We import the algorithm, the isolation forest algorithm, and then we load our data set to just be able to work with this. This is a new data set. Then we can prepare the data set for isolation. So by the way, here again, when you're preparing it, you could include other numerical variables that you want to work with. The challenges have those numerical variables. So yeah, so feel free to also work on the challenges and consider that. Then we initialize the isolation forest and set contamination to 0.1. Normally, this is usually the value that we use initially for isolation forest. And we set the number of estimators to 100. The number of trees to use for this particular case, and random state, so that we are able to get the same outcome for isolation forest. We need to have random state as 42. Like if you want to get the same outcome as me, you also get the same thing. We set it just to 42. Then we fit the model and predict the anomalies. Based on the transaction, based on this amount, then we store that those anomalies in this particular. We predict. So you will see that we have 1 and -1. So -1 will be an anomaly. 1 will just be a normal record. That's usually how it's interpreted. So here in our case, we have 1. We've created this new record, and we now then decided to display the outcome of our data frame. So anomaly here, for the ones you see, these are just normal records. But if I wanted to check for the ones that are -1 anomalies, I can run this, and I should be able to get records which are anomalies, which are the ones that you see here. And that's it. You can, once you've identified anomalies, you can then just decide to investigate them further closely to just check whether they are actually anomalies or not. Because sometimes, maybe someone just won a lottery and decided to transact a lot of money. You can't blame them for that. So it's their money, Yeah, so work on the challenges, pause the video, and then work on the challenge, and then we can wrap this session up. All right, so that's it with regards to this learning experience. The next step, just work on projects, try to look for a data set that works, and in terms of maybe transactions, has transactions, and apply the different techniques to just all the different techniques to that data set, and come up with some conclusion about whatever that you're working towards. And the idea is that you will have acquired a skill that you can always use to come up with a solution when it comes to just working on solutions that demands anomaly detection. Yeah, so that's it with regards to this learning experience. If you found value, if you think that we did a good job, be sure to give this video a thumbs up. It won't cost you. And if you'd want to be informed when we post such future courses of videos, be sure to subscribe, and see you in the next